Hi guys, Mathemagic here. Today we're going to be going over calculus from first principles, that is understanding where our knowledge from differential calculus really comes from, the bare bones of it. So we know calculus has got to do with finding the gradient of the tangent to any graph. That is, the tangent is only a line that touches the graph once, so if we find the gradient of this tangent, that is essentially what calculus is. Now, from first principles, we're dealing more with the gradient over 2 points. That is, if we have a point here and a point here, what is the average gradient between them? So as in, if we drew a line between the two of them, what is the gradient of that line? And we know from linear algebra that the gradient is just going to be y2 minus y1 divided by x2 minus x1. Now if we have our y1 point here and our y2 point here, we find the difference between them. That's our rise, and then we divide that by the difference between the two x coordinates. That's our run. So we're just going to get rise divided by run. We can write this a little bit more sophisticated. So let's write, instead of using y, let's use f of x. So we know if y is going to be f of x, by the way, if we have a graph, say y equals x squared, that we have here, that's just the same as saying f of x equals x squared. It's just really a substitute for y. It's slightly more sophisticated in the sense that it is a bit more diverse with what it can do. So we can call y1 the function of x. Now we need to wait to quantify the distance between them if we're going to use the function notation. So if we call the distance between these h, we can call y2 the function of x plus h. If we add h to this x coordinate here, and then we take the y value for that, that is essentially just going to be the function of x plus h. It's as simple as that. Now our x2 point here, it's going to be x1 plus h, so we're going to have x plus h, and then we're going to subtract just our original x coordinate. And this really is what the first principles are based off. So we can just write this as f of x plus h minus f of x divided by h, and that is the basics of first principles. But let's get a bit more complicated with it. So in maths, there is a concept called limits, written as lim, and that is a point on the graph where the y value is going to approach but never actually reach. So if we write, imagine our x point is approaching a, and the limit of f of x is going to equal to whatever that that point is that y is never going to reach. So if we have the graph y equals x squared, this would look something like f of x equals x, where x is an element of all numbers excluding, let's just do a dot there, excluding 5. That means that all the numbers along this graph are possible except for the point where x equals 5, because that open dot means that we can't actually include that value. Now, so if we write the limit of our function of x as x approaches to 5, we're just going to say, we can sub in 5 here. The function of 5 is just going to equal 5, so our y coordinate is also going to equal 5 at this point. So we can say the limit of our function as x approaches to 5 is going to be 5. And having an understanding, or at least a basic one, of these limits is going to drive our understanding of first principles. So let's get right into an example here. So using our power rule, if we have a function of x equals x squared, we know that the gradient function, or the derivative of this, is going to be, bring the 2 to the front, take 1 off the 2, and we're going to get 2x. Simple as that. So that means if we have the graph y equals x squared, the gradient at any point is going to be 2x. Now, how are we going to do this using our first principles? Well, we know that the gradient is going to be function x plus h minus function of x divided by h. So if we use our function x squared here, we're going to get x plus h squared. So you replace x with whatever is inside these function brackets, minus f of x is just going to be equal to x squared divided by h. If we open up these brackets, we're going to get x squared plus hx plus hx plus h squared minus x squared divided by h. And if you make this look nice, the x squareds cancel out, these add together, then all the h's cancel. We're going to get 2x plus h. Now we've got our 2x here for our gradient function, but what are we going to do with this h? Well, if we find the limit of 2x plus h as h approaches to 0, that is, as this h value gets smaller and smaller, as these points get closer and closer together, infinitely close together, h is going to essentially approach to 0. The distance between the x values is going to get so small that we can essentially call it 0. That is to find the tangent. So if h is essentially 0, we can just do 2x plus 0, and that means our derivative of this graph from first principles is indeed 2x. So key takeaways: remember this formula here, and remember indeed limits and how it works, especially in regard to this. I hope you guys have gained an understanding of where our power rule and where essentially all of differential calculus is based from. Thank you very much for watching.